Welcome to Topology Protocol Community Call number 2. We have 2 items on the agenda. Number 1, we're going to offer some updates on the development of the protocol, and 2, we're going to make some announcements.
Are the announcements good?
We'll see. It's the next slide.
Are you too surprised?
We're not going to the next slide before covering this slide, which is a lot.
Yeah. So basically the protocol development updates, we separated in 2 categories, which one was the things that we already done, and the other ones is the things that we are currently working on. And the things that are currently done, it's a shame for the topology team, because all of those stuff that is listed there, it was done by the interns. So we currently have 2 interns. We have they are in the community call today. One introduced himself just now, which is Jan, and then we have also João. And they've been responsible of implementing the built-in for the CRDTs that we want to have in our core package. And they have been doing a great job, a super awesome job. They implemented already a couple of them. We are now pausing those developments because we might need to refactor them in order to support other features like Plasma. But we are going to get back to those after. And about that, one of the first things that Jan did, I'll answer in 1 second, None. One thing that Jan did as soon as he arrived was actually building a new example for our code base, and he built a chat room. So in the super near future, we might just ditch Discord and just go to the chat there. Just need to implement like voice and the reliability and every the cool stuff that it's not as easy as it seems. So it's really funny when people say, "Oh, then why don't we rebuild chat applications?" Chat applications are not that easy. So it appeared a question here in the chat about what is a built-in. And basically, we define a built-in within the CRDT packages as not only CRDT, but also for the CROs is the CROs, which for people new here stands for conflict-free replicated objects, which are based on CRDTs. They are supposed to be constructs of other type of structures, and those structures are either CRDTs, basic CRDTs that exist in the wild, or other CROs. And the built-ins is CRDTs that are pre-programmed by us and are available for anyone to build on top of those. Does that answer the question? So the thing is, for example, a built-in in our case, for example, is a GSet. The GSet is a type of CRDT, which is a grow-only set. That's a built-in that we implemented. If you are trying to use a set, which is a thing that exists in the standard libraries of most languages, nowadays you can use them, but in theory you are not supposed to do them while you are constructing the CRO. And the main reasoning why you can't use those is because you might break some constraints while you are building your CRO in terms of convergence. So when you are building a CRO, CROs are also CRDTs, and one of the key properties that they need to hold is the convergence of the state. And if you just use standard stuff like maps, sets, even arrays, you easily can break those constraints of convergence. So, difference between CRO and CRDT. CRDTs is let me think how to do this, explain this in an easy way to understand. You can correct me if I say something wrong there. CRDTs are structures that hold specific properties about convergence of state, in the sense that you can always converge to the same state as the other people that are changing that data structure. And And the thing is, you do that with specific rules. In case if you have conflicts, you have predefined rules that everyone agrees that they are going to use those rules, and because of that, you are going to end up with the same state. CROs, it's a new construct that we are building. That CROs are in fact CRDTs also, but any CRDT is not a CRO. So we have an equivalence of all CROs are CRDTs, but not all CRDTs are CROs. And the thing about the CROs is CROs had some other nice features, like the part of you can actually check all the operations that you did. You have a history of the operations that you did for changing the state and all of that. Although those operations can be pruned. But that's one of the main things. Apart of that, we also have other things like the part of BFT, ensuring BFT within the CRO itself. That's something that we have planned. And that's mainly it. Gigi, you want to add something there?
I think that's a good summary. I think CRO is CRET plus a lot of useful things that make it much more useful in the real world. So for example, we intend to introduce a notion of finality on CRO. So with CRDT, you don't have any finality defined. Basically, CRDT is this thing that eventually it guarantees convergence. Everyone will have the same thing, but it's eventually. You don't have guarantees on when that convergence is going to happen. It depends on many things. But with CRO, we intend to introduce finality so that for applications that want to use CRDT but also benefits from having finality, CRO gives you that. And that's just one example. There are other examples. Basically, more capabilities provided on top of CRDT and also below CRDT. CRO is an object that is interactable over the peer-to-peer network. So if you use CRDT, it doesn't necessarily assume it's running peer-to-peer. But with CRO, we're going to make it so that by default it's running peer-to-peer without you having to worry about the networking complexities.
Yeah. I'm just writing down something. Yeah, that's exactly it. So we have a question here of what is the infinite phase set, and Yen was the person that implemented that one, and that's why he's already answering. And if you have any questions, he can actually explain you super well on how to implement that. If you are interested, he just said about the extension of the 2P set. Do you also know what a 2P set is? So for everyone else, 2P set is a two-phase set, which is you have two grown sets, one for add stuff, one for removing stuff, and you can check if something is within that 2P set by checking if it's in the add set and it's not on the remove set. That's the basic 2P set. The infinite phase set is an extension of that. That allows you to insert and do it many times. I didn't understand the question about what other libraries is it used in. What is used in the infinite phase set, or what? So most of the built-ins that we are implementing are literature built-in CRDTs. So we are, because we want anyone that develops CROs to be able to have whatever CRDTs are available in the research side. So most of the CRDTs that we are implementing might not be used in the wild in any protocol, but they were researched and they were well defined within some paper, and we are implementing those based on that. So lots of times they might not been used at all in the wild yet, but they might be used in the near future. We also, so that's something that we have here on the development updates for the something that we are working on, which is the documentation, and all these CRT built-ins that we are building. We are actually start building documentation around those, explaining what they are, how they work, and what can they do and what can they not do. So after we don't have it ready yet, but in the near future we expect for us to have lots of documentation on all the implementations that we did, and also the references for the original papers that define those CRDTs. And that's a new check on the working on the documentation. So the documentation we are currently, we have two types of documentation. We have a super technical one for the JS library that we have, that is based on JSDoc. I don't remember if it was JSDoc or something else. But that is for you to find all the functions that exist within our library, and also some comments that we added there. And the part of that, we are also starting to build a more beginner-friendly documentation on what's the purpose of Topology protocol, what's the purpose of CROs, some of the basic concepts for people to understand that, and all of that. Related with that, we are currently also working on the specs. This is actually quite big thing, because the specs are the main driven force for implementing everything. Although implementation is not dependent on specs, specs define a super good approach on if you want to have reproducible behaviors across different clients. It's the specs that are going to define that behavior and how everything should work. So even right now, lots of times while we are developing stuff, we are not super sure on how should we implement some stuff. And if we already had better specs there, we already had a clear roadmap on how to do stuff. So right now we are developing the TypeScript client. In the future, we are intending on implementing a few more. And when we are implementing those few more, with the spec already well defined, we are going to have a map where we can say, oh, for implementing this part, we just need to do this, and this. Then there are always the language specifics, but a part of that, it's going to be easier. We assume that's going to be way easier. And other stuff that we are working on, we start working on better logging systems for everything. Currently, we were using the typical console logs and console errors for everything. We don't want to have that. We want to have a better logging system where you can define the logging level that you want to have on the application, if you want to even have logs or not, because you might not want logs at all. And we are also doing that now. We have some other built-ins on our pipeline, but like I told before, those built-ins are dependent on big refactorings that we are currently doing in the library. And those two big refactorings, now we are moving to the two biggest things that we are currently working on, which is Wasman protocol. So those are the big stuff that we are currently working. We are refactoring almost all of our code base to have these on board. But this is basically what is going to enable us to run everything super efficiently across different clients without needing to worry about running on different languages. So I'm going to start with Protobooks because it's arguably the smaller one and the one that it required less effort until now. And basically, we just defined some so for people that don't know what protocols are and why are they used or why are they used, basically protocols is a way of you defining some structures that can be serializable and deserializable to bytecode and to JSON and whatnot. And the thing about protocols is that the way that when it's serializing to a byte array, it makes it in a super efficient manner. And the thing is, since the protocol structure is predefined and it's pre-known for everyone, when you are serializing it again, you know the structure and you can just unfold everything perfectly. And the main reason why this is super important is because of two things. One is when you want to store stuff on your disk and you want it to store in an efficient manner that doesn't occupy much space. That's super useful. But for us, that's not the most important case. For us, it's a network, because since networks are some spaces that are super resource constrained. So when you want to send something to someone else, you want to have the less amount of data going through the cable. Then you need to have smarter ways and proper ways of reducing the maximum the amount of size that you can. And Protobox is one of the state-of-the-art stuff that people are currently using. A part of that, also the things that so the things that protocols enable you to do for serializing and deserializing stuff, it's super awesome because they provide you stuff out of the forgot the word. I forgot the expression. But as soon as you start implementing protocols, it's super easy for you to serialize and deserialize everything into JavaScript objects, TypeScript objects, or if you are using other languages, even structs in Rust or whatever. So that protocols are super awesome because of that. And we are started already implementing those. We are already finished most of it. But the protocols for interacting with the object, because protocols are mainly used for the CROs to be sent over the network. And a part of the CROs, some of the updates also for the network. And the thing is, when we started implementing protocols, there was a big dependency on the running functions on the objects, and that is something that we already had working, but the way we had working was super cumbersome. And we didn't thought much about it because we already knew that we wanted to implement WASM to run the functions within the CROs. And because we already knew that we wanted to have WASM, we didn't care much about the initial implementation for everything to work. But now that protocols require also that, we started giving more focus to WASM. And now we started also to implement WASM. This has been being an effort for I think we started actually working on WASM since the last community call. So this is an effort that is already been for a while. We had lots of feedbacks on the architecture that we are using to do everything WASM related. We had super good feedback. So the person who started to implementing WASM was Mujan. Then after I finished up some stuff on my side, I joined him and started implementing WASM stuff with him. And I've been discussing also with someone that is here in the audience, which is Kiwi B. I always call him Kiwi. I don't know if I'm offending him or not. Kiwi, if I'm offending you, tell me. He's been helping us a lot, giving us feedback on our WASM architecture. He has lots of experience with the assembly script, which is the thing that we are using to do everything WASM related. And currently, so here is an open question to everyone that is in this call that knows a bit about WASM or assembly script or what structure should we have here. And basically the current structure that we have is we are doing our CRDTs and CROs with the constraints of assembly script, which is required for it to be compatible to WASM. And the thing here is, so CROs and the CRDTs need to be compilable to a compiler that is assembly script compiler, and we are compiling that within our code. So actually, people that are developing CROs don't need to carry about compiling the code. We are doing that within our code. So when errors appear there, people need to fix those errors. And the thing is, when everything is compiled, then we actually, instead of putting the outputs to a file, we actually fetch the bytecode and put it to some wrapper structure. And that wrapper structure basically has all the bytecode for the WASM. It has the ID for the CRO, and it also has the ABI, which is the interface for the functions that exist within that WASM bytecode. And the model the thinking model that we had for this is that this is the best structure that we could think of, that we can make it interoperable within different clients. And here we stand the big question for everyone here, and or for your friends, if you don't have anything to talk with them over coffee, if we are doing correctly, or if there are better architectures for us to do this. And if there are better architectures, what are they? Well, what should we consider? What should we not consider there? And this one has been tricky. It has been being tricky because we've been spending some resources on thinking about on how to do it, and also testing, because no one on the team had previous experience also with the assembly script. So we've been, and everyone that works with assembly scripts within the team, every time we work with it, we just dislike it a bit more because of the constraints that it has. So even I can give you one example that's ripped almost my ears off for assembly script, which is they don't have closures. So if you have variables, the variables need to be defined within the scope of the function. So, for example, the super nice functional programming that you have in JavaScript, like you want to iterate something and you just use a for each, you can't. You need to find another way of doing it. Even the typical for some variable of some array, you don't have that. Even the standard library, most of them, it's not even compatible. So we were using sets. We had to re-implement the set logic, because assembly script also has sets, but the function that the sets, the standard library of sets of assembly script is totally different from the TypeScript one. So for some functions, in TypeScript, it expects some argument. On assembly script doesn't expect any. So because of that, we had to learn new stuff here now. And basically that's it for WASM. So this open question, it's going to stay around in the air. We are still implementing everything WASM related, so we are more than able to change the architecture if we learn about a new thing that is better. We have all of our channels open, so you can just comment on whatever we said here and ask questions and suggest better ways of us doing stuff, and we are totally open for it. Gigi, do you want to go a bit over the spec stuff?
Actually, before that, I think for the audience, just for context, maybe it's helpful to say why is WASM important for us at all?
Oh, okay, sure. So let's think it in a simple way. So we have some state. We want to update that state. right? For that, we need to execute some code. The thing about executing code is if you are all running on the same language and on the same stuff, you can easily say to everyone, oh, I just updated this, you update that on your side. And everyone is happy about it. Thing is, when you are mixing lots of weird environments and people that don't have TypeScript installed on their machines and they actually have binary, you need to build some binary for something and all that, you want to have different clients with different languages. And the thing is, then it's not that easy to make it compatible. So you need to have some kind of VM that is runnable on all of those environments. And the thing is, when you say WASM, you can use any kind of VM. So you can use Java, you can use CRO, you can use the EVM, you can use whatever you want. It works. The thing of us picking WASM is because WASM is the most interoperable VM that currently exists. You can actually run WASM in all kinds of different environments and weird environments. So that's why we started picking WASM. But actually, on our roadmap, we have implementations of other types of VMs. So in the future, people are not to be constrained on having the need of doing everything and have everything on WASM, but they can actually use other type of VMs. We have that on the roadmap. It's not a priority right now at all, but it's something that we intend on implementing.
Nice. Yeah. So moving on to spec, I'll keep it short because this is an ongoing effort and a lot has to be decided still. But the spec reflects how CRO should work. What is the interface of the CRO? What is the internal structure of the CRO? What can you do with CROs? And when you do something with the CRO, what kind of behavior is your action translated on the networking side of things? The spec won't be super detailed on this just yet because there's really a lot of moving parts. But the spec provides a roadmap or a foundation on which we agree on how everything should work in a rough sense. And when the spec becomes more detailed, as we develop the TypeScript implementation, adding more features and improving it, eventually the spec becomes the connection that we can use to go to other programming languages and build Rust clients, Go clients, and so on and so forth. But right now, the effort is mostly on making progress on the concrete TypeScript implementation of the node, and also reflecting what we know into the writing of the spec.
Mm-hmm. Yeah, I think that pretty much sums it. The spec also currently we are working a lot on the CRO spec, but even the CRO spec, it's something that is extendable to lots of smaller details. So, for example, even the WASM protocol protocol for sure needs to be defined there. WASM, not that much the WASM stuff, but the structure that we have for the wrapper where we have the WASM bytecodes and the ABI and all that inside. Yeah. Yeah, I think then we can move on to the announcements.
Yeah, I think there's one more thing that I can bring up before we move on. It relates to the question, earlier question, what makes CRO different from CRDT? And I brought up finality, but I think I can explain it a little bit more on why that's important or why that can be quite useful. If you have so without finality, you have a CRO, right? And you have Alice, Bob, and Charlie all having a copy of the same CRO locally, and Alice, Bob, and Charlie are all doing stuff to their copy and synchronizing with each other. So at any moment in time, if you look at what they have, the three copies, they pretty much will diverge if they're all working on it at the same time. If you have finality, you're basically saying Alice, Bob, and Charlie, maybe not unanimously, but representatively agree on what the CRO state is. And it's a singular state. It's not a bunch of copies anymore. It becomes a singular agreement representing what the state is for the CRO. And what makes that useful? You can, for example, send that finalized state of a CRO to a blockchain, and you can use that to trigger something that happens on some blockchain, because we know transactions on blockchains are not reversible, right? So when you do something on the blockchain, you need to be careful. And without finality, you would have a lot of people working on the CRO at the same time, and they don't necessarily agree. They temporarily diverge on what they have, so they can't interact as they are with the blockchain. But when you have finality among them, you can use that to do something on the blockchain. So that can spawn interesting use cases, but I don't think we're ready to do use cases there. But I think intuitively, I hope this makes it clear that why having finality for CRO, which is not something CRDT has, can be useful for the crypto native crowd here. Okay, next.
I've been looking into the questions. Super interesting questions.
I actually don't have access to the. I'm sharing my screen.
Chat?
Yeah, I don't. Yeah, I can't access the chat. Yeah.
So another thing, if anyone wants to jump on site and speak, you can just ping on the chat that we. So if we usually ask beforehand if people want to brought some topic to the community call. This week, no one told us anything, but even though that, you can just ping us here and join. So we're fine.
Mm-hmm.
Yeah, go ahead with the announcements.
Nice. Yeah, come on stage anytime. Okay, announcements. First, white paper is going through the final revision process, and it's going to be public by the next community call, which is August 21st. Okay, so we've said it, we need to do it. Second announcement, we are planning on doing a Topology Hacker House for Topology Protocol during Korean Blockchain Week, and this is the first week of September in Seoul. You have the application form for the Hacker House here, big QR code, scan it or share it with your friends who you think might be interested in working at the frontier of what CRDT can mean to the world. And I'm saying this not out of hyperbole, because CRDT has been a technology that existed for quite a long time, more than a decade. It has also gone through its own hype cycle, but we have yet to see large-scale adoption of CRDT in different domains of technology, and there are reasons to that. And one ambition is for go ahead.
Just wanted to interrupt to say one thing. I really love that you said in a broad area, because otherwise, actually, CRDTs are used a lot within specific areas, and they are used by lots of people without them knowing that they are using.
Yeah, I think if you ask like an average database developer, I think that high probability they will know CRDT, or they have used CRDT with their architecture. But I think in terms of people that are more on the application side, writing application software, I think quite a small percentage works firsthand with CRDTs in their applications. For example, I've yet to know any production level multiplayer games that use CRDT technology underlying. I may be very limited in my knowledge, but I don't think there's a large scale adoption of this, at least in the game industry. And one idea is maybe Topology Protocol can change that. And indeed, in the white paper that you will be reading soon, and in a lot of our thinking, CRO is meant to enable multi-user real-time interaction. So guess what? One obvious use case that is for multiplayer games. And it doesn't have to be a game, right, with the win-loss condition. It can just be a virtual spaces where people and agents can interact in almost real time at this concurrently. It doesn't have to be a game at all. Okay, so if you're interested in building something interesting with CROs, anything, this Hacker House is for you. And this is the very first Hacker House. Things will probably be a little rough, but you will be working at the frontier and with us closely.
Yeah. So anyone is interested in joining us in September? No? Oh, sad. No one is writing on the chat, so it's sad. No one wants to join us.
So join us. Telegram, Discord, GitHub, and that GitHub links give you the TypeScript implementation of the protocol, which has the most activity at the moment. And now we're at the AMA section.
I'll do the AMA works during all the call. If people just write on the chat, we just answer right away. So this is the time for final questions.
Mm-hmm.
I'll tell anything.
Any questions, or if you have anything you want to share, come on stage. We'll accept you.
Everyone is so shy because it was the second call. But by the 5th, everyone will be on stage having a rave. We need to have as a goal by our 10th community call having it in some other space like Penguin World.
Yeah,
in the 10th.
Awesome. Mm-hmm.
Yeah. Kono is asking, when CRO Platformer World? Exactly. Our 10th community call.
Yeah. Make a CRO for CC. Yeah.
That should be our goal. You want to jump around? We need nonsense help. He's the master of platformers. So I think there are any questions. No one is raising up anything.
Mm-hmm.
So just share with your friends the Nonsense is also asking if the YGS community call is happening. You know it?
Yes, YGS community call happening on the first Thursday of every month. We're missing it this time, but we were invited to share something in the next one in September if we want. And indeed, Penguin World was built on YGS, so we can share that.
Yan is asking how can you create voice chats with CROs, and the answer is you don't. You don't create with CROs. You do it with the WebRTC. You just send the voice packages over the network. It's the same. It's the same thing as Presence. In Presence, you might want to use a CRO for that because you might want to have constraints on the Presence mechanics. But even for Presence on you saying that you are somewhere, you don't need a CRO for that. In our previous demo, we didn't use CROs for that. We used CROs for the big canvas that we had on our example, but for showing people jumping around on the space, it was just people sending messages to everyone saying, "Oh, I'm moving this way." Yeah, some people want to jump, some people want to fly. No, we need the imagination on it. But yeah, I think that's a wrap then.
Yep, we can wrap up. Yep.
Wait, I have a question. Was this filmed?
I think so.
Kono. Answered. Filmed? Yes? Okay. I forgot to ask before. Okay, good.
Nice. Okay.
Then you, I don't know how much time it took last time, but yeah, within the next days, week, you should expect this to be uploaded on YouTube, and you can just review it if you want.
Yay.
No, they already saw you in the West community call.
We're actually strictly on time because 45 plus 7 is 52.
It's more or less that. Yeah.
Yeah.
But yeah, then everyone, thank you so much for joining us tonight.
See you in the
Or
next
today
community
for you?
call.
I don't know. For me, it's tonight.
GMGN.
See you in the next one.
See you in the next call. Bye, everyone.